name is Sandhi Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller and embedded systems design having code KEC 061, what we have covered, we have completed our 3 units, and the previous lecture, last lecture, we have started with the unit number 4, and we have seen that unit number 4 is all about the Internet of Things. So, in the previous lecture we have covered the some basics of IoT, what are the various building blocks of IoT, and we have seen the typical IoT components and the various applications of IoT. So, in this lecture we will see some more detailed explanation of IoT. So, 4th unit is introduction to IoT, and here we will see the evaluation and main technologies of IoT. So, these are the table of contents we will cover in this lecture. Internet of Things, we will more getting the data about the Internet of Things, outline the evolution of IoT. We will see here the history of IoT, how it will discovered, in which year, how IoT works. We will see the working principle of IoT, how the IoT devices work. After that, we will see the main technologies that enable IoT. So, in IoT, we can use various types of technology. We will see here in this topic. After that, we will see about the protocols and standards which can use in our IoT device. So, these are the table of contents we can use in our IoT system. We will cover in today's lecture. So, what is Internet of Things? In the previous lecture, we have seen that IoT is basically a Internet of Things. It means that it is basically a connection of physical objects. Objects is a things. So, various types of devices are connected with each other through the internet. They are capable to exchange data, communicate with each other by using the network. Okay. So, there is a networking between all the devices. So, basically IoT is a dynamic global network infrastructure of physical and virtual objects and have unique identities. That means that all the things which are connected to the IoT has a unique identification. Why it is unique identification? Because one device, there are numerous devices. If there is no unique identification, how that one thing can be connect with another thing, and how we can able to identify the particular device. That's why each device has a unique identification, has we can say that has separate identity, okay, which are embedded with software. We can use the software, sensors, actuators, electronic and network connectivity to facilitate intelligent applications. Why intelligent applications? Because all the devices which are connected to the IoT are intelligent. They are capable to take self decisions, okay, and by collecting and exchanging data. So, from here we can say that sensors, connectivity, people and process, as we have seen in the previous lectures, are the key elements of any IoT system. So, we have taken some definition from the internet, IoT definition by the ITU, Gartner definition. The Internet of Things is basically a global infrastructure for the information society, enabling advanced services by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technology. So, basically in IoT it is a global infrastructure, it is used worldwide. So, it is basically a world in which we are using many types of devices, all are using sub technologies here. The Internet of Things is the network of physical objects. We have seen in the previous lecture that it is basically a network of physical objects. It's objects that can be physically recognized, that is some deploy or implemented in the environment, okay, by using some hardware that contain embedded technologies to communication among the devices through some connectivity techniques like wireless techniques, and sense or interact with their states or the external environment. That is a Gartner definition. So, there are various types of IoT definitions. Some people say that IoT Internet of Things, some say that it is basically a Internet of robotic things, some say that it is basically a Internet of drone things, Internet of embedded things, Internet of all, because it is used in everywhere. Internet of we can say that Internet IoT, IOMT, Internet of medical things. Okay. So, there are various types of definitions full forms, etc. So, but basically IoT is that all the devices are connected through the internet, that is IoT. Okay? That is a one line definition. So, let us in this slide we will see the history of IoT. History means evolution of IoT. So, evolution of IoT, outline the evolution of IoT. Evolution means that the concept of IoT is first became popular in 1999 invented by Kevin Ashton. So, the term IoT is first coined by Kevin Ashton in the year 1999 through the AutoCAD Center at MIT and related market analysis publications. So, Kevin Ashton first coined the term of IoT. Okay. After that, there are has been a various types of definitions, but first Kevin Ashton proposed this IoT term. Radio frequency RFID was seen as a prerequisite for the IoT at that point. Okay. RFID is the main technology enabling IoT. Okay. So, here you can see in this diagram, we are evoluting from the pre-internet to the internet of things. So, pre-internet means that human are connected to the human from some mobile phones in the 30 or 40 years back. You can see there large size of mobile phones. We can send SMS, basically calls. Okay. So, human to human connection in between through the internet. After the internet of content, that is introduction of internet only, not things. World Wide Web was there. We can chat with each other, entertainment, we can watch movie in the World Wide Web net, email we can do, information can be transmitted. So, here the smart networks are added plus smart network, yani ki human, that means human to human data interacted, we are adding the smart networks here. After that, internet of services we are using for e-commerce application, e-productivity, web 2.0. We are adding the smart networks plus IT platforms here. After that, we are again adding the smartphones and applications that evaluated from internet of services to internet of people, that is internet of people, that is people are connecting with another through Skype, Facebook, YouTube, WhatsApp we are using right now, that means plus smartphones and applications. Smartphones are coming. Smartphone means that phones which is capable to do more functionalities in addition to the calling and the messaging. And so, after that, internet of people means people are connected with another people. We have replaced human to human with the machine to machine, that is things are connected with the another things through the internet, that is internet of things. So, that is basically machine to machine communication. So, IoT can be used in identification, tracking, metering, monitoring, semantically structured and shared. So, what we are doing here, smartphones are converted into smart devices, and finally, we can use from data analytics and various applications. So, this basically this is the history. We will go more into the history of the IoT. The first telemetry system was rolled down in Chicago way back in 1912. So, in 1912, first telemetry system was proposed. So, at that time it is said to have used telephone lines. We have used telephone lines to monitor data from power plants. From power plants, we can deploy telephone lines to communicate. So, we are using only telephone lines, as we have seen in the previous slide. Telemetry means long distance communication, expanded to weather monitoring in the 1930s. We have used telemetry to get the to track about the weather conditions when a device known as a radio sound. Radio sound is basically a device which is used to in the environment, in the balloon, so that it can track the environmental weather monitoring. It is basically used for weather monitoring, environmental data we are getting through radio sound, and it became widely used to monitor weather conditioning from condition from balloons. After that, in 1957, after 27 years, here it is 28 years and 18 years, and after 28 years, the Soviet Union launched Sputnik, and with this space range, the Soviet Union launched Sputnik in the environment, in the space. So, they are communicating with the earth. This has been the entry of aerospace. Aerospace means we are using the space technology. We are that means the earth is connected to the satellite, that means the aerospace. So, telemetry Telemetry means we are connected with the satellite, two-way communication, created the basis over global satellite communication today. So broad adoption of M2M technology began in the 1980s. In 1980s, M2M technology has been emerged out. So with wired connections for SCADA. SCADA means that supervisory control and data acquisition. SCADA is used in the PLC devices for the data analytics purpose. Okay, control and data acquisition on the factory floor and in home and business security system. So these are the, this is the history from the 1912 to right now in 2022. We are using the millions of devices are connected with each other. In even in satellite through so we are connected our devices. Okay. So that's why we are able to watch the various types of channels. DBS, direct broadcasting satellite, is example of this. GPS, through GPS we can track any vehicular movement. We can say that we can observe the distance between the two devices. Okay. So right now we are using various technology. So the first we have seen this slide. So in the 1990s, we have seen that in the previous 1980s, after 1980s, 1990, 10 years after, M2M began moving towards wireless technology. We have evolved from M2M, from wired network to the wireless network. So Adamco built their own private radio network to address intrusion and smoke detection because budding cellular connectivity was too expensive. After 5 years, in the year of 1995, here Siemens introduced the first cellular module built for M2M, and we have seen that in 1999 Kevin Ashton first coined the term Internet of Things. So concept of Internet of Things came into the year of 1999. Before there we are using M2M, but they are not connected through the internet. Okay. So RFID was seen as a prerequisite for the IoT at that point. If all objects and people in daily life were equipped with identifiers, computers could manage and inventory them. So we are using many types of objects and M2M communication with things are connected with the things. Things are connected to the people through the network. There is network between the devices. So besides using RFID was using in the IoT, the tagging of things. Tag means the things which we can tag in the IoT system may be achieved through such technology as near field communication. NFC through NFC we are like card we are using in ATM machines. We can tag the we can use barcode reader to to scan QR codes. In today life you can see the Paytms or Phone Pay. We can use for e-commerce purpose. We can pay amount to another by using the scan techniques. That is the barcodes we are scanning. There is a scan means we are using the UPI ID. Okay. So all are possible through the IoT. Bluetooth technology we are using it, digital watermarking we are using, all our devices using the IoT. Okay. So we can say that how IoT works. IoT, the Internet of Things, also sometimes referred to as the Internet of Everything. We can see in the previous slide that IoT also say we can call IoT as the Internet of Everything. Why Internet of Everything? Because everything, many devices, each and everything we can connect to the internet. That becomes the Internet of Things. Consists of all the web enabled devices that is able to collect and send and act on the data. We can collect the data, we can communicate the data through wireless, and we can act on the data means we can do data analytics techniques. We can collect useful information, we can extract useful information from the data we have collected from the sensors, and they acquire from their surrounding environment using embedded sensor, processors and communication hardware. Okay. So these devices means objects we are talking about, things we are talking about in IoT, Internet of Things, often called connected or smart devices. Why it is called smart devices? They are capable to send data whenever needed by the human being. Okay. So it can sometimes talk to other related devices, a process called machine to machine communication. So we can, in 3 words we can say that IoT is basically a machine to machine communication. Machine like our smartphones, our washing machine, our microwave oven, all are smart enough, and all are objects or things which are connected to the wirelessly to the machine which is has some remote location. Okay. So, humans can interact with the gadgets to set them, give them instructions or access the data, but the devices do most of the work on their own without a human intervention. So, what is going over here? All the devices are capable to connect with the other devices without human intervention. There is no role of human. There is only a hardware which can be through some software we are enabling that hardware, and through this hardware and some in hardware there may be a processor, there is some wireless techniques, all one machine is connected to the another machine. So, their existence has been made possible by all the teeny mobile components. So, that are available these days, as well as the always online nature of home and business networks. Okay. So, this is the working of IoT, how the IoT devices work. Okay. So, now the question is, what are the main technologies that is used in our IoT that can enable IoT system? First one is the mobile computing, second one is the little devices and little data, standards that enable internet scale like with Wi-Fi, these are the standardized network, 3G. Right now we are going for a 5G, we are using 4G, but soon will go towards the 5G technology, LTE, long term evaluation, Bluetooth, smart browsers, JavaScript, HTTP, TLS, etc. WebM community based development like ecosystem enabled by trust, for example, embed HTML. Let us we are going to the detail of all these. Mobile computing, basically mobile computing means the device, mobile computing means we are using the smartphone here, smart tablets here, all are low power devices, and we can do many tasks through our smartphones. We can control our home electricity, home appliances by using the smartphones. Little devices and little data, what means? Devices are little means we are miniaturization the things are becoming small and small day by day, cost is low, power consumption is low, and functionality will be more, and we can send little data and embedded devices, for example, wearable sensors. Standards, we are using that technology in IoT like Wi-Fi from wireless fidelity network. We are using the Wi-Fi device in our home to connect with the routers for surfing purpose. 3G, okay, LTE, long term evaluation, it is, we can say that we are using the VoLTE. What is VO? Voice over long term evaluation. We can send in net, we can also using we can do video calls. How video calls can be carried out through, this is using by using the VoLTE type of technology we are using right now. And Bluetooth low energy smart browsers, we can use the various types of browser like Chrome, etc. JavaScript, HTTP, hypertext transfer protocol, through which we can serve the devices, we can open the web browsers. TLS means transport layer security. It is basically protocol standards through which we can connect the one device to the another. TLS, or we can say it is there is some another term SSL. SSL means security, socket security layer. So, TLS, SSL, these type of protocols we are using to send the data, to communicate that our hardware with the remote servers. Okay. So, there should be some protocol standards. Without standards, one can prepare, one can do hardware, one can collect data with from anywhere. So, there should be some protocols so that effective communication can be done between the devices. Web and communication based development ecosystems, embed basically a open source software which is used in ARM processor. Okay, HTML5, all are using, these are the technology that we are using in our IoT devices. Here you can see that mobile computing. Computing means we are in mobile phone, we are using the ARM Cortex board processor. Here you can see that when you are switch on the mobile, you can see this picture. It is basically we are activating the processor. Here we are using ARM Cortex A. A means application processors. So, here we can use iOS. iOS is used in Apple devices, Apple mobile phones. Android is used in our mobile phone that is other than the Apple devices. Here we are using the various types of devices, 3G, Zigbee, LTE, Bluetooth low energy, Wi-Fi, LoRaWAN. We can also use long range wide area network. Okay, so all are connecting with the devices. These are the wireless technologies. Okay, so they are using some protocols, IEEE 802.15.4. IEEE means International Electronic Standards, Electrical and Electronics Association. So we are using some standards here, 802.15.4. These are the standards which is acceptable globally. So if any company in India and any company in USA, all are prepared these types of Bluetooth, these types of wireless devices by using these types of protocols. These are the fixed protocols. This is globally acceptable. Without following these protocols, I am taking some example. In laptops, we are using the USB port. If we are using some standards and protocol to prepare that USB port. So if we are purchasing laptop in India and in USA, if the USB devices is manufactured by using some protocols, so the devices we are using in India, USB devices, same device can run in USA by using these protocols. If we are not following these protocols or standards, it may we can say that the size of the USB port may vary. And even if Lenovo or ST, any laptop, they are bound to use that standards and protocols, so that the thing we are using in particular device can run into another devices. Okay, from purchase from anywhere. So little devices and little data means ARM Cortex processor technology. We are using in devices, chips, applications, big data analytics can be done from here. And we are using ARM Cortex M. M means the microcontrollers boards are using. We are using the processor. After that, ARM Mbed. Mbed, we have seen that basically open source platform which is used in ARM processor. So here you can see that there are a lot of devices. Smart watches, smart TVs, smart umbrella, smartphones, all are connected with the platform. So hundreds of millions of devices are connected. So we can say that it is a web and community based development. Okay. Here you can see the more technology. ARM Cortex A. A means the application, R means the real time, M means the microcontroller. So these are the ARM Cortex board we are using it. So ARM Cortex A family applications processors basically used for applications for rich OS, rich operating system, third party applications. We are using ARM Cortex A family of processor. ARM Cortex R means the real time. Embedded devices are based on the real time. Real time means no delay in the system. So embedded processor for real time. Real time signal processing, data analytics, we are using ARM Cortex R family. For control applications we can use ARM Cortex M family. Is enabled for microcontroller oriented processors. For microcontroller, M means microcontroller unit. ASSP means application specific circuits. That is, application specific means the device which is used manufactured for one application can be dedicated to that application. For example, washing machine. In washing machine we can wash clothes. In microwave oven we can prepare food, but microwave oven cannot use for washing of clothes. That is the application specific. System on chip. Basically microcontrollers are system on chip. All the things are embedded into a one chip. So here you can see ARM Cortex board. We can use Wi-Fi, Bluetooth, Cortex sensors, Cortex or gyroscope sensors, application processor A5 to A7, A9, Cortex A15, control units here. Okay, Cortex MD processor, flash computers, cellular modem, NFC sensors. All the devices are enabled on one chip. So these are the technology that is used in our IoT device. So ARM Cortex A class processors, it is used in applications that have high computing requirements. So A class processor means application ARM Cortex board are used in which high computing requirements are there. Like high computing means where data analytics is high. Okay. It is used in rich operating system, deliver interactive media and graphics experience. If you are going for to use for laptop for gaming purpose, you can deploy these types of ARM Cortex. You can use this ARM Cortex A class processors. Here you can see that this is the performance versus the year. So when we are going from the 2011 to to 2022, the performance is increasing, functionality will be more. So the devices which are used in 2011 like Cortex A5, A8 all have small frequency. So we can say the A5 processor using the 400 to 800 megahertz frequency. When we are going towards the Cortex A8, frequency increase from 800 to 1 gigahertz, and when we are going from the one generation to another, the frequency will increase. Here you can see that Cortex A9 processor using the frequency of 7 megahertz. We are integrated more devices. Cortex A7 has a 100 megawatt budget architecture alignment, and when we are going from the ARM Cortex A5 to A57, the frequency will increase, number of bits we can handle more, functionality will be increased, performance will be increased, and efficiency will also increase day by day. So here you can see that miniaturization will be more functionality, less cost, low power consumption devices when we are going from one year towards the another. So here little data starts with little devices. Here you can see that the nodes, these are the is capable to provide the data to the servers by using the local processing techniques, that is wireless techniques. Here you can do security, communication, discovery, applications management, data storage and analytics, all can do in the cloud. So all the data getting from the nodes, data devices go to the cloud. From in cloud we can use data analytics techniques. Bluetooth smart connectivity, Bluetooth low energy. Bluetooth basically this is a symbol of Bluetooth. It is used to run from coil cells, that is 10 megawatt power supply. Short range communication we can use only for short range, less than 100 meters. These are the small devices. Okay. Here we can see the microcontrollers, radios. Microcontrollers we are using rapid and professional IoT development and open source platform libraries. So libraries are available in the Cortex M microcontrollers, we can use them. Mix and match essential components for your product design like Bluetooth, LoRaWAN, Wi-Fi, cellular, sensors, software tracks, radios. Simplify integration, we can cloud services like embedded agents, API, nano services. So basically these are the technologies that enable IoT device, that are using an IoT system. Protocols and standards we are using billions of things, 2G, 3G, 4G. Right now we are going towards the 5G, trial is going on, low power WAN. So these are the wireless technology, Bluetooth, Zigbee, Thread, Wi-Fi, wireless PAN, wireless WAN, 2G, 3G, 4G, 5G, GSM, okay, CDMA, UMTS, LT, other technology, satellite, DSL, fiber, PLC, Sigfox that is used in the European country, long range networks, weightless, NB-IoT, narrowband IoT, all are using these are the technology of IoT, all is, that can enable any Internet of Things system. Okay. So thank you everyone for your patience. I hope you have enjoyed my lecture. In next lecture we will see some more about the IoT. Thank you everyone.